Great to be here, James.
Super, nice to have you. So I'll make an introduction here. We have Mr. Chris Blask, who most of our cybersecurity, CyberSenate community know. He's author, speaker, supply chain attestation for Unisys Applied Innovation, Mr. Chris Blask. We're also joined by Eric Byres, the CEO of Adolis Technology, Ron Brash, Director of Cybersecurity Insights for Verve Industrial Protection, and we are joined by Bryan Owen, Security Architect for AussieSoft. Is it AussieSoft or OSIsoft? I've heard a couple people say it differently.
We'll accept either, but OSIsoft is my.
Thank you for correcting me. Appreciate that. So we're going to get kicked off here. We've had quite a few conversations over the last few months with many different infrastructure sectors from transport to energy and beyond on supply chain. And we had a great conversation last night, actually, panel session as well to end yesterday. And, we keep digging in on supply chain. And really, I think we all know that, there's that in that supply chain panel, we were talking last night, Jake Margolis, who's coming on later today, really good panelist and speaker, was talking about how we had to develop a more resilient strategy, really, because there's no silver bullet. We're not going to get ahead of this, but what we can do is we can treat our business as a risk, and that we're in the business of risk, as was stated, and to make sure that we're prepared and that we're ready. What I wanted to dive a bit deeper into is, what we are doing to make sure that products that are entering the stream, the supply chain, are more secure, and how we can work collectively to do that. So without further ado, I'll stop my little rant here and ask, how do we better manage cyber risk throughout the development and deployment process? This is a hardware and a software discussion, I would imagine. So Ron, will you kick us off? I know we've gone back and forth on this a few times already.
Sure. I guess youngest go first. So I think there's three different perspectives here. There is the asset owner, which is probably going to be most of the audience, and then you're going to have the OEMs, the vendors, which I actually more or less equate them to actually integrators, because they're actually kludging together and gluing stuff together. Buying chips off the shelf and soldering on the boards, taking board support packages, giving you all the features you want from ABC brand, right? They're integrators more than anything, just like Boeing, building aircraft largely. And then you have the suppliers that provide the components to the OEMs that they're doing the gluing together. And depending on where you are and where you sit, I think that's probably a good way to start this discussion. And there's different people here, and we're all from different product backgrounds, but maybe that's a good handoff. I just want to mention the first point, depending on which perspective you are, you're going to go down a totally different road. And maybe, I think Bryan had some great insights in his email, so maybe I want to pass it to Bryan next, perhaps.
Thanks, Ron. The supply chain has been very much in the news now. I don't know how many times SolarWinds has been mentioned. It's almost like the new Stuxnet, right? Everyone is talking about it, and we know that it's like an iceberg. There is a lot of work to do there. I think every software supplier has really looked at what happened introspectively to see what more we need to do in our processes. But let's not get too distracted and allow knee-jerk reactions to carry the day. We really need to approach supply chain with facts. And that's kind of intentional pun for Eric Byres and his FACT program, but we really need facts to drive the decisions we make in supply chain. It's just going to be too hard to tackle this with a knee-jerk, willy-nilly kind of approach.
I'm going to agree with you. I see people trying to do supply chain with spreadsheets, and supply chain is so complicated. We're never just dealing with the immediate supply chain. We're dealing with third party, fourth party, fifth party, sixth party suppliers. And I come at this from the perspective of both an asset owner at one point and then chief technology officer at Belden. And, I didn't know as Ron says, an integrator of a product, but, really building firewalls and switches and stuff like that. I really didn't know what my development teams around the world were integrating into our products. And I definitely didn't know what my suppliers they were using and what sub-suppliers they were using. And I think that's true. It's just really, really a complicated problem. And we have to start to throw some automation and some techniques to this to just, rather than just say, give me a list of all your suppliers. That's not going to work. It's got to be something that we build up a community and that we sort of automate all that technology together so we can get that information automatically, not by phoning each supplier and trying to ask them for a list of his suppliers.
You think that may not work, right? So this panel is a great end to an arc for me, because I got involved with James and the CyberSenate through the ICS ISAC, which is being rebooted for everybody who knows us. A lot of the folks here are part of that in the past. And it was all about situational awareness. In that case, threat intelligence and how do we get communities together talking and sharing information. And now we're talking about, frankly, the same thing, but it's more situational awareness. Where do we get the information that tells us, as all three of you said, as Eric, you said a lot, that I, as the provider, even know what's inside my own stuff, much less anybody else's. And this, the digital bill of materials arc started really late 2018. And as I look back at it, there was a panel at CyberSenate, October, I think it was, in 2018, where Marty Edwards and Tim Roxy and I think a couple other people were on the panel, and Gear, made the statement that there is no supply chain security, right? So we've been driving down this path for a long time, for decade or decades, if you want to look at it that way. But in this period, in these last 5 years and 3 years, a lot of the things we'll talk about today, no doubt, have burbled up, have gotten a level of maturity where they can be actually used. And because I like a lot of these things, the things that bring us, people like us, together for these events all the time, we can all see a future where we can't keep doing things the way we are. Each of us, I as Unisys now, or Eric Bizdola, or whoever we are, in 5 years and 10 years and 15 years, if we have as little understanding of what's inside the stuff that we're responsible for, we're probably not winning. So you can see the paths, and they're similar to each of the other paths that have happened in careers of all of us here.
James, you're on mute, so I'll just jump in here
Yeah,
for a second.
no, I keep doing that. I think 3 days of conferencing's probably killed me. So jump in, please.
Yeah, I was going to say, this is not just a vendor OEM problem. It really is an asset owner problem. There was a great quote that I heard the other day from a federal official who said the FAA, the Federal Aviation Administration, has struggled for weeks to identify how many servers it had even running SolarWinds software. So, and I mean, this can happen. You don't have to have a contract with SolarWinds to have SolarWinds software on your site. Anybody out there who's using GE products is highly likely to have SolarWinds components in there, because GE redeploys a lots of SolarWinds. So, and that chain just keeps on going. So as an asset owner, you want to know what's running on your plant for bad days like SolarWinds. You want to know if you're going to be impacted. Otherwise, and this happens all the time. I see vulnerability notices going out and people don't know that those impact them because they just know who they bought it off of.
Yeah. And as as Unisys, I mean, we're the world's oldest computer company, been at this stuff forever. We make huge systems for banks. And to be clear, everything I say has been said in public forums. But when a customer like ours, like Citi, who's been working on, the product development issues, the CI/CD custody issues internally, says we're going down this path, then vendors like us listen, right? And I like the frame for this panel there was a DevSecOps podcast recently, because it's not about supply chain. It's about product development. You know, in a world where I'm developing products for banks or utilities or whatnot, what can I do and when do I do it, and what drives that change? And there's a lot of things driving that change now. The software bill of materials space is getting relatively well known. It's in this sort of mid-90s firewall space where lots and lots of people are involved. Everybody knows, everybody there knows about it. The rest of the world hasn't really heard about it, but they're all going to, and it's relatively well defined. And this digital bill of materials attestation structure seems to, be getting to a level of maturity where it'll probably go forward, or something like it. So you can start to see the shapes of how we, as product developers, meet the needs that our customers are going to giving to us and our competitors, and what steps we go down that path.
I'm just going to call some people out because I feel like it. And I know David Doggett, you're listening in. And David, you gave a fantastic presentation yesterday on embedded device security, and we warmly welcome you into this stage if you want to join us. Sorry, Ron or Brian, were you?
No, thank you. Actually, that's a good call out. So I try to look at this a bit differently, because an SBoM, depending on which audience you are, as I mentioned earlier, will change how you use it, right? If you're an asset owner, an SBoM on its own isn't very helpful unless you integrate that into your technology stacks and your processes, right? Like, try to go to a NERC audit for NERC 13 and have a metric ton of SBoMs in front of you with no context, no new pieces work in those products. You see a Linux version that has 700 vulnerabilities, but the reality is maybe only 100 of them are actually in there. 10 are actually applicable because those interfaces are implemented in a certain way. None of that is really captured there, and only the vendor really knows what's going on. And hopefully they know what's going on, and they're just not regurgitating what came from the VxWorks supplier upstream or whatever. So there's lots of aspects here that you need to carry forward. I try to think of supply chain not as its own domain. It's actually really an extension of risk management and vulnerability management. And if you look at it very pragmatically, which I'm trying to do here in that same sense, it's just an extension of all of the things that you have, just that you're given more insights. How you use those insights and what those insights are in is really going to be the game changer. We're really still early in that infancy of understand, or that process of understanding on where we are, how to use those things. And Brian can probably attest to how hard it is to say to people, hey, yes, because we use that library, it's not vulnerable because we do A, B, and C, right? Like, people are just going CVE hunting. This is really tricky stuff. And Eric mentioned, right, people aren't checking those data sources. There's too many data sources. Every OEM has their advisory portal now that isn't tied into NVD. And ICS Cert is doing whatever it is. And you have Aruba products with a Siemens name on them, and the CVEs don't match. And I know Oasis is coming out. I got grilled on that the other day. But that'll one more standard just complicates everything again altogether. So there's a lot of pieces there that you need to glue together, and it is a risk management exercise, right? Supply chain leads to understanding your risk for your organization or that set of assets, and so you need visibility. And I don't want to shameless plug what I do, but depending on where you are in those three perspectives, everything really changes. And you don't know what your developers are putting in your products half the time, right? I mean, like SolarWinds, I bet you if even the first person that wrote the code, I doubt a peer review would have found it. I highly doubt it. And Eric can probably say the same thing. So there's a lot of risks here, and it is risk management. That's what it is.
Well, and to define a couple of things for people and use that as a lever to explain why I think this is moving forward. So a software bill of materials is exactly what it sounds like. It's a bill of materials. It's a list of ingredients, contents about a piece of software. And as Ron's just saying right now, that's great. You obviously you need those, obviously. Next step, and you're going to get them. That train has left the station. People on the screen and out in the world and in public and private sector going on that path. Next step, what are you going to do with all those? Well, they got to be put in some sort of context, don't they? Because there's too many pieces. So you get these inevitabilities where people are going down the software bill of materials perspective, which, sticking to our topic here, product development, means that developers are going to have to be formalizing their process, but enunciating what's in something. And in-toto is another Linux Foundation project that gives you a taste for where this is going in product development. all of that is at creating attestations about the custody of the software you're developing. So now I have the final bill of materials and I have attestations about the custody. Where the digital bill of materials or DBOM structure comes in is a system of attestation nodes and channels. We can talk about it very like some other place, but that's where the attestations go. So that, close to the utility, the consumer that Ron's talking about, there's some set of channels where they can see things that have been attested to by somebody they're doing business with or already have a relationship with, and they can act on those. And then the vast sea of information beyond that, like threat intelligence, the huge number of SBoMs and custody and handling and HBoMs and MBoMs and so forth, don't get that far down because they can't. So,
I think you nailed it, Chris. To me, SBoMs are just a tool that we need to use to help the software developers make a better product, understand what risks they've taken on through third-party code they've integrated. And by the way, everybody integrates third-party code. And for customers to understand what risks they're acquiring. And I liken it to a can of soup. I go to the grocery store, I pick up a can of soup, I see the ingredients on the side. Unless I understand what those ingredients mean, then they're just names on the side of a can. If the can of soup I have includes monosodium glutamate or says palm oil, and I don't know what that is that good? Is that bad? Should I? So unless you take the SBoMs and then enrich them, you've got really nothing. But the SBoMs allow us to enrich our knowledge about a software package and the risks we're taking.
Maybe.
Yeah, it's a foundation. Sorry, Bryan.
Yeah, if I could jump in for a second, because I know, a lot of things we're talking about. I'm imagining that there's people listening that are thinking, wow, this is great, but it's not going to help me with my plant right now. It's almost like a control loop, right? We're way out here on some cascade loop, and the inner loop down in the plant isn't getting any help, right? The time constant for new products getting into the field that maybe have been built better and all that is just so long. So how do we deal with the supply chain issues for things that are in the field today? And there's part of it, of course, is understanding what you have, and tools like FACT, or maybe some people have come across CyberITL, where you can scan a binary and tell whether it was built with even the modicum of memory protections, and just try to get a feel for where the technology is in the security life cycle. So understanding your assets better in the field. There's also initiatives like EPRI-TAM is a wonderful one for not just looking at the bits, but understanding the data flows that are going in and out of a product, help you understand that attack surface a lot better. The AHA project out of Washington State University is another one that is just super simple, give you a 0-100 score on your attack surface. So getting away from guessing about what the posture of the software is, and having more facts to help you prioritize where the issues are and how to act on them is important. And the last piece, and I'd like to throw it out to the audience to comment, is we need to do a whole lot more testing across the entire supply chain. There's some testing that is best done early in the development chain, and suppliers are doing that, but there's some that needs to be done at the handoff, whether it's factory acceptance or customer acceptance. And then there's ongoing testing that needs to occur as well. And the security research community has been great at that. Quite frankly, they're often showing us where we need to get better. So, what are we doing for the testing, and how can we, to use Chris's words, put those in to the some kind of a mechanism to share that testing so everyone's not having to reinvent the rule or reinvent the wheel. Sorry.
Dave's commented in the chat, if you guys can see that, and maybe comment.
Well, right. I was going to use since this is the CyberSenate, there's a great OT example of this is the business drivers. Sometimes security is adopted because security, quite often is because competitive advantages are driving changes in markets. And, since most of the world I work in these days is not OT, everybody here knows how much fun it is to trot that out. You start talking about a plant engineer, and a plant engineer using a real-time data system, a Unisys partner, we've gone all the way down the path with this, who can say that this last batch of materials coming in performed differently, based on the source of that content. To be able to as a manufacturer say to the product vendor that I'm manufacturing products for, I will not ship any product to you that doesn't meet your requirements, like it's gone over a set degree temperature in the shrink wrap tunnel, and having that automatically attesting itself into the same structure that we use for the security purposes we care about. So and the origin of DBOM was an internal Unisys conversation. It's like, look, we buy, and again, all public information, we buy from Dell, we sell to Citi. We don't need to solve the world's problems. We can just save money ourselves by being more clear about exactly what we're getting, exactly what we're doing with it, and exactly what we committed to. We've identified multiple annual repeated expensive things that happen we can avoid. So we're getting into these sort of cycles where, David, to your point, we have, SBoMs are pretty well done. In the US, there's an executive order coming out any minute now that's, as far as we can all tell, it's probably going to say SBoM. The US Department of Energy Citrix program is going down that same path, and they're probably going to use the DBOM attestation structure, right? Just because they need to. And it's where we have business values in doing these things that we as security practitioners can say, look, it's not just about being a good corporate citizen. It's about lowering our cost and reducing our customer support response cycles so that we can be more profitable and competitive. Executives like that, and they will give you budget to do your security things when you can say that.
Well, David, I don't know if everybody saw David's comment, but I think it was really good. We can start to understand how many and what components come into our code, but how do we get a handle on knowing if you have genuine unchanged version of all those? And I think that's one of the important things that all the SBoMs in the world would not have helped us on their own to find SolarWinds, because that was genuine modified code, that came from the development center, and it was signed. It was, but what the SBoMs allow us to do is to do two things. One thing immediately, they start to allow us to be able to say, hey, now there's a problem, and I'll go back to my FAA example. We know there's now some bad code. How do we go and find it where it's deployed in the real world? And obviously the FAA didn't have a way of doing that. And I think that's what we have to address, is how do we know what you're actually running on your plant floor? But the second thing that I think is really important is once we start to get there, one of the projects my data scientists are working on right now is a counterfeit detection. Because if we have enough samples of what is legitimate, we can start to look at what shows up either because it hasn't come through the development center, because it's been signed in a non-standard way, or because the code patterns and the compiler bits aren't the same. We can start to say, hey, I can't tell you for sure that that's counterfeit, but it is an anomaly. Just like we use anomaly detection on networks, it's anomaly detection in software. That component is anomalous compared to what I've seen come out of vendor XYZ for the last year.
Well, this leads, I think, directly into what you were saying, Ron, that, once you get to that point, there's the now what, where you're going, Eric, so the now what is, okay, so I do know that I do have that code. It is deployed at that spot in my network, and perhaps I also know that all the network ports and traffic that could possibly be used for that are disallowed by the network architecture right there. And that is, under continuous monitoring. And I would get an alert to my SOC if that ever changed for a second. So maybe I don't do anything about it, but you have to have all those pieces in the stack. And if we're going to go down the SBoM path, and we are, then each of these other paths is going to follow naturally.
And there's some actually other stuff. I'll circle back onto David's question earlier, because there's a lot to unpack out of that, and some of it will be beyond some of the audience's head and some won't be. Don't get me wrong, like hashes don't solve the world's problems, especially on embedded hardware where every single binary will look different from another one. And there's issues around that too, right? Like how you compile for your Intel CPU might look totally different on an ARM CPU, right? Because of the different interactions of the hardware. And no SBoM is going to help you get that. Even a hardware bomb probably won't get you, right? You're dealing in the land of errata. But there's another interesting aspect here too from a business driver is to produce bill of materials and do assessments pre-acquisition by large organizations as a way to discern the risk before they even look at purchasing X amount of products. I mean, Eric and I in our previous life, Eric used to be my boss. We actually had people show companies and buy our product, and then we had to go deal with the assessment results in a past life. And you know, SBoMs would have been something very helpful there. You know, even for our part to understand it. But there's a whole world there. But for that customer that wanted that assessment, and actually we've done it a couple times, it gives them a big stick to improve the product that they're about to purchase, or at least to negotiate certain things with the integrator, the vendor. It's really, really powerful stuff to help manage your risk before you have that risk unconsciously transferred upon you as the asset owner. And I think that's a really critical part of how that pieces are there too. So that's one piece as well. And then the other piece I wanted to sort of unpack was on David's question is, how do you know if you're dealing with vanilla or unadulterated code or unmolested code? I can almost tell you without a doubt that most of your systems that you run have patches in them and are not even anywhere close to what your original expectation were. Yeah, maybe libraries will be the same. Like for example, like how you would use like libzip or libssh for sure. But the Linux kernel, anything that has any adaptations on top of it, if you've ever compiled stuff for OpenWRT, you will know that there's a 50 million layers of patches. They all get quilted together. And then you add compiler flags on top of it and all of these specifics. And it is a very nuanced understanding. So when people say supply chain, this is at the current point in time, it's a thumb to the wind, and vendors can use this as a way to improve their products, right? To get a smell test, especially for Internet of Trash. This is very, very critical stuff here. Very, very critical stuff. So I won't take it over, but I just want to feed the rest of the conversation.
Now I have quilted together stuck in my head. But to Andy's points in the chat, what I find interesting as indication that we're on an arbitrary path. This is not situational. It's not because of individual events. Is that we have a series of executive orders from two very different U.S. Federal administrations that go down the same path. And the first one goes, back to the regionalism you mentioned, Andy. The first executive order was China bad. And again, separate from personalities and administrations. At that point, it's understandable. That was the first public comment about DBOM, is that you can understand that need. It'll need to be refined, but we're going in this direction. And the new administration has an executive order out that seems to be reinforcing going down the same path. So we need to be able to say, whichever country we're representing, maybe there's another country we don't trust at the moment. We need to know where their stuff is. And that both allows defenders, where those fears are real, to behave better, but they also allow better cooperation, because you don't have to assume that everything from everywhere has everything in it. Yeah.
And also too, I mean, Andy had a good point. And Ripple 20 or whatever your branded set of vulnerabilities are, they're in the source code and not the binary. So as I said, the vendors are integrators and they can apply their own patches. Even different compilers might even add guard code and make those irrelevant, right? So what goes into a binary isn't necessarily what comes out of it. And fingerprints are one way to look for it, like if there's symbol tables or stuff like that, right? You can get an idea. But if you scrub all your binaries, which is a security best practice, then you're dealing with a whole nother can of worms, if you will, right? Your soup might not be the same ingredients that you expected. And let me tell you, there was some research done at CS3 last year, and they were ripping apart a Schneider device, and I was chuckling, and I messaged the gentleman, the researcher on the other end. I said, how many devices did you destroy, and how many different variations did you get? And he's like, we had 5 or 6 different hardware variations of the same product in the same package, which to me also means that the Linux kernel is using different drivers at runtime to deal with certain things, right? It might actually be the same source code, but the end result is different. And that's also something the FAA also struggles with error worthiness reports. So there's a lot of things there. And the presence of a vulnerability in supply chain or a risk or an vulnerability does not mean exploitability, right? So I'll rephrase that in simpler terms. Let's say you have a vulnerability in Microsoft's remote desktop protocol stack, but you have RDP disabled. Are you really at risk, right? Maybe someone could turn it on for sure. I'm not going to negate that. But are you at risk because of the overall situation? And so if you have other assets with RDP enabled and they're on the internet or in a place that's, has more exposure, you're going to target those guys first. And vendors will do the same things too on understanding which, where the dead bodies are, the skeletons, if you will, and try to match around that. But it's very complex. And the more we go to stack, web stacks and all these fully featured ones, I don't know if you've ever seen developers say, import everything that I need in Visual Studio. They do it, and they don't know what they're accepting. This is the reality of where we're going. And we, as Chris said, as Eric said, and that's why James brought us here, and Bryan can probably attest to how tricky this is as moving towards, open source components and products. We need to get a handle on this.
Ron, thanks for mentioning that. Just because a vulnerability is in there with it may not be exposed. It's so important, and we have to also value stability, not just security. That may sound like heresy in a security conference, but stability is related to security and in the availability piece in particular, which is so important in ICS. So I really think we have to accept that no one wants to be on the vulnerability patch hamster wheel. It doesn't work in ICS. And we need to get smarter about understanding exploitability and having mitigations that are easier than patching. And in the longer term, you're exactly right, Ron. We'll have to simplify devices. We can't be bringing in entire web server stacks into every device. That's not going to be the formula for stable, successful software going forward.
Just look at BusyBox alone as it's an embedded shell that has, it's a utility knife. And I can tell you it's got FTP in it, it's got Telnet in it, whether or not it's enabled, it's going to have DHCP, it's going to have everything in the kitchen sink and possibly even your grandmother to go along with it. And we need to start limiting all of those surfaces today. I know that people will say, well, like it's like when you buy a car, it's got everything, including Bluetooth, even if I didn't want it. It's all there. I wish I had a choice, but we need, as Bryan said, we really got to start minimizing these solutions and really getting a handle on it. I mean, that was the great thing when hardware had no resources, because you were forced to go through these processes and clean it up. There was a benefit. You knew what every little bit of code was doing. I mean, it may take many of the real-time safety systems microcontrollers, and FPGAs, right? They weren't these commodity devices with a ton of RAM and shared in. It wasn't there, and it is today, for right or wrong, and it's enabling new sets of innovation and disruption. And I appreciate that, but you're letting yourself out. Just as like on the internet, you share everything. Well, the same as in a device. If you give everyone the keys to the kingdom, I don't even need to bring exploitware onto your device. You gave it to me for free, like I did in the Sans ransomware attack. So you got to start doing some due diligence there and having your developers be responsible and accountable for what they're bringing into your environment. And if you're not, you're playing a catch-up game. And so again, I'll pass that off to the others, because I think that's an intriguing point.
Well, given our last couple of minutes here, I'd like to address a question that I hear all the time, which seems to emerge from this sort of conversation, is that's a lot of information, right? And it sounds to me, like the early internet days, it's like, well, it's just all this, what am I going to do with all that? And the answer is you aren't. You're going to do with some of that. And so just imagine that you could have all that information about software bill of materials and handling and custody and patches and threat intel and everything else. Which bits do you actually want? And these last use cases in the last couple of minutes touch on that, because again, if you have all of the supply chain stuff in the world and you put it on a critical server that you then don't monitor and you put on a flat network you're still dead. Right. So all of this supply chain information plays into context where you say, I actually need that software bill of material and this type of software bill of materials and these 3 enhanced software bill of materials on this device because it's very expensive and critical. And I put in the monitoring, and I put in the network architecture around it, and I know I actually care. You can't do that for every asset you have, by definition. And you won't need to. And Ron's used the word attest a couple of times. And this is, you know, the you know, and for my own bias and filter, it all gets very simple because you're already attesting to each other. You know, Andy, you've got so many direct customers as Schneider. You have all sorts of relationships with them. You attest to each other about all sorts of things. You know, that will continue. You don't, you know, impossible things won't happen. Unisys and Schneider and, you know, OSI Soft are not going to have direct relationships with every 5-person company on earth. And not everybody gets everybody's IP. You know, everybody gets what they need, and we go through the process of defining that.
So I'd like to jump in and circle back to Andrew's comment about in the chat about regionalism, and Chris, you mentioned it as well. But the reality of the world we live in is that governments are disposed to banning products. Countries of origin will need to be tracked, and SBoM is the primary, or at least the leading mechanism for tracking that. So if for no other reason than preparing for government orders, we really, as a community, need to get these SBoMs built and built right away.
Okay, guys, we've got about 1.5 minutes. So I'm going to take the opportunity to thank Eric, Ron, Bryan, and Chris for joining us. It's a massive conversation. I really want to put together at least a 1-day event on this and just invite as many smart people as I can. You know, I was having conversations after this SolarWind thing with rail operators in the United States, and there's a few that just said I can't speak, as they were going to speak, but now I can't speak. They said I'm dealing with this SolarWinds thing, you know, and it's just shocking how many asset owners are actually dealing with you know, the fallout of these problems that we're discussing, and how few people actually, you know, in those asset owner roles are really sure what to do, you know, other than prepare for the fallout the best way you can, and be ready to bounce back, you know. So anyway, thank you, gentlemen.